Here's where we left off in the last video. We're getting ready to turn the second time on the OD here to get the actual finished shape of the part. Just saw me indexing the roughing insert. This is going to be kind of a theme in this video of indexing inserts on this roughing tool, because you can't really make two passes. You can try, but it'll just, the insert will fail before it gets to the end of the second pass, so it's just easier to index the insert. And these roughing inserts aren't real expensive, so it's not that big a deal for me. This is the way I'd rather do it, rather than trying to stretch an insert out to get the last little bit out of it. It just isn't worth it, and it could dig into the part, into the finished size when you get close to the finished profile. Here's the finished turning tool. Index the insert again. I usually set this tool up a little bit, maybe 5/1000ths of an inch, and take a pass just to kind of get my bearings here. You never can tell, might have some little discrepancies or something, and it's better than screwing the part up. To take another finished pass is not that big a deal. So I take this pass and then mic the part. I put that mark on there because there's quite a few different diameters. They're very small increments of change. It's hard to tell where one is over the other, so I put that mark on there to know where I'm marking the largest diameter. And here's the second pass with the finishing tool to bring it to size. There again, this insert on even the finishing tool wears pretty quickly, so you don't get too many passes before you have to have it to size, or you're not going to make it. And then you're going to have to back off in the offset and rerun a new insert. So see, that's one diameter, and then there's a different diameter there, and a different, well, that diameter is the same as the one behind it, and then the smaller diameter at the end. And all these have about I think they're about a 3/1000ths tolerance on them, +0, -3. I didn't like the way that tool looked, so I changed the tool. I'm retouching it off. This tool just roughs out the middle groove. Because those holes from the end of the part intersect this groove, a turning tool in this material, you just really can't rough into that intermittent cut with a turning tool, like a grooving tool or a turning insert. It just, you'll see later on in this video where this little spot face thing I put in for indicating the part gives me trouble with the rough turning insert. And that's much smaller than those holes are. For some reason on this particular part, this is the fifth, I think it's the fifth part I made this video on, of this part of it. These shavings, I had trouble with these shavings. I didn't have this trouble on all the other parts up to this point. There's some variations in this material enough to cause this issue, where the shavings just were getting balled up on the part. I also had a little trouble with that on the rough grooving tool that grooves out the smaller, which actually are O-ring grooves. I think these grooves are just for like some kind of maybe wear rings that fit on the OD of this part, possibly. I'm not sure. They do have a 2/1000ths tolerance, which actually they have a closer tolerance than the O-ring grooves do for some odd reason. You can actually, I don't know if you can hear it on this tool, but on the finishing tool you can hear it when it intersects those holes, which is odd because I couldn't really hear that when I was outside the machine, but when I ran this video I could hear it in the, I don't know if you can hear it on this tool. I think it was the finishing tool that you could hear it. You can actually hear it intersecting those holes when it takes a cut over them. So this is the back turning to get the full width of these grooves. So that's what the these wider grooves look like, just roughed out. Here's the rough grooving tool. Here again, indexing the insert. And there's a narrow groove right there, and then there's two wider grooves on the other side there. And here again, I had a little bit of trouble with these shavings on this part, which I didn't have on the parts before this for some weird reason. I don't know, there must be a little slight variations in this material enough to cause this part not to break the shavings for some strange reason. I had to stop it and clear these shavings off in a second here. So that's the roughing groove tool, and there's actually chip breakers on that grooving insert too, so shouldn't have really had that much trouble. So that's what all the grooves roughed out look like. Those O-ring grooves, of course, have to have a real nice finish on them, so I have to come back with a finishing tool after this, after the roughing tool. This is the finish OD tool again, and I'm using it to finish these wider grooves with. So we turn as much in the forward direction as we can. And those three wider grooves. It's going to go down into the deeper one next. I'm going to turn the tool around and come back. Now on this, when I do this, I offset the tool upward, and I usually make that turn when it's turning backwards. You probably could hear it now hitting those holes. That I make that turn a little bit larger diameter so I can mic the difference in the offsets so that I can blend the offsets together to each other very nicely. So that's the first pass on those grooves. And here I'm miking the two different diameters that the two different tools left, and I'm trying to decide how to change the offsets. That's why I'm kind of looking at it and miking it quite a few times. Checking the width. They're about 1/1000th too small on width, but that's in tolerance. So here's the final finish cut of these wider grooves. And hopefully I matched the offsets good so it'll look, so that you won't be able to see it. Notice how the part looks like it's turning real slow, like the shutters in synchronous sometimes. It's using constant surface footage, so it's actually varying the RPM. See how it looks like it's barely rotating? It's kind of interesting. You could probably hear it cutting over those holes again on that finish cut. So now they're to the size that I want. And notice there's no mismatch in the two turning tools now. I don't worry about it on the roughing tool, just the finish tool. Here's the finish grooving tool. This happens to be a Sandvik insert on this one. There's a lot of cool. This particular tool has a big coolant hole, so it's kind of hard to get any kind of good picture of this. So I kind of cut out most of it, really. Although it's kind of hard to tell unless you know the actual tool path. But it was in the high pressure coolant, and the coolant hole is quite large. and it's really difficult to get a decent shot of that. So here I'm miking the diameters. I actually set this out a little bit thinking that it would be large, and it turned out to be right on size. I was kind of lucky. I did change the offset bigger on that tool. This is the beginning of the J slot, roughing it out. There's J slots, on little ones on the end of this part. That's a tricotal roughing cycle to rough it out. And it comes back with a finish pass, and then it rotates slightly. You may not be able to see it, but when the tool comes up, that's the finish pass. Now it rotated, I don't know how many degrees, 15 degrees, and it had to do that end of the J slot is at it's like a wrapped contour, if you will, but it's just as easy to do, to rough the whole thing out and then rotate the angle and do the end of it. They're both the same, except this one on this side has an additional pocket on the OD for some reason. I'm measuring the width of them, the calipers. It's got a pretty wide open tolerance actually on the width, but got to keep track of it. This is a little pocket next to the J slot on that side, and I'm not sure what it does, but it's on the drawings. Have to put it in there. That's a similar roughing cycle, the tricotal roughing cycle with the same end mill that I roughed the middle groove out with, and this is finishing it with a 1/4-inch end mill because it has small corner radiuses. I have to use that smaller end mill. And check the depth of it by miking over the OD on the other side. Now that's that little counter bar I use for the indicating to make sure that bronze overlay is in the right location. When I go to rough turn this OD, you can see how, and that little bitty counter bar gives me a lot of trouble in this material. So you can see why I didn't want to rough into those holes in that bigger groove. I slowed the feed rate down in the program right at the hole too, just in an attempt to get through it, and it sort of works, but it can break the insert. You got to pay attention. So this intermittent cut on this kind of material, see, that's the insert on the first pass, the tip of it going through that hole causes that. And then this pass, this second pass, you'll see it actually breaks the whole tip of the insert off to get finally through that little hole that I put in there. But I needed that because I need to keep a reference to that bronze overlay that's on the other end of the part. When it comes to mill that, it has to be in the right location. So you can hear it when it hits it right there, and now the insert's broken by this point, so I stopped the machine. And see, that's what the insert looked like. So cutting through intermittent cuts, turning, I should say, through intermittent cuts on this kind of material is very difficult to do. It's not really that it's that hard, it's just a really tough material when it's at this heat-treated stage like this. This is 718 Inconel at 150 KSI minimum yield, but it can be higher than that sometimes. There is a double heat treating process that improves the machinability of the material, but it wasn't done on this stock, so I have to live with what I have here. So that's the first roughing, and then we got to come back in here and rough out a groove, or an undercut, back turn it, I should say, with this 35-degree diamond CNMG insert, so that I can get that roughing tool in again to rough down to the smaller diameter. And this I really don't have too much trouble with. I take very shallow passes on this tool because of the weak insert. I just don't want to break the tip off of it. And I can do that whole roughing with one tip on that tool. But I'm not pushing it very hard. So we got to index the insert every pass. This is, of course, sped up quite a bit faster than it's going. The chuck is actually only turning about 100 RPM on these roughing passes, because that's as fast as I could turn it and get any life at all out of these inserts. About 100 surface footage. With that smaller diameter, it's probably turning a little more than 100 RPM, but the OD is almost 4 inches on the part, so when it starts, it's turning around 100 RPM. Here's the finish tool. Index the insert again. Cut the back turn first, and then turn around and cut up to the chuck. Tried to cut as much out of this video as I could. That's why I'm jumping forward in a lot of these passes, because what you're looking at is actually over a day's worth of machine work. And I've cut it down to around 27 minutes long in this video, so I had to really cut a lot out of here. Here's miking the OD of that smaller diameter. And this is a tongue-alloy feed mill cutter. I've had good success with these tongue-alloy feed mills. They work pretty good, and their grade of inserts holds up pretty good. It's a 2-inch diameter feed mill. Just going to rough the flats off on that section in the middle there. This also looks strange. See how the tool looks like it's hardly rotating at all? I guess the shutter speed of the camera was right in sync with the spindle speed or something. It looks like it's barely turning. This actually roughs both sides of the part like this. You can only see one side. I didn't see any point in showing you both sides. It's the same thing all over again. Kind of get the idea from this. Actually, this tool worked pretty good in this material. This is a tongue-alloy drill as well, I believe. And I've had really good success with this style of drill that they make too. I like the insert. You can index that insert 6 times on that drill. It's a kind of a negative rate kind of an insert. And for drilling tough materials, that style of drill has worked really good for me. So that just drills a start hole so I can get this plunge mill in there. Now this plunge mill, actually I'm showing this cycle, but I had to index these inserts quite a few times. I'd get about 6 to 8 plunges. So I just set it in the program that every sixth plunge it would move over and I could index those inserts. And just so I didn't have any trouble with the tool, and I didn't want to break the tool or inserts or anything to waste cutting edges. I don't show me indexing it every time, but that's what it took to do this. I'm not sure if this is the fastest way to rough this slot, but see how it moves over. I'm showing that one. I have to index the insert. I actually had to index the inserts 10 times. It uses not quite 6 inserts to rough that groove out. I did it with 4 inserts initially, but it's really hard on the tool, and so I decided to be safe and just do it, slow it down a little bit. This is an ISCAR feed mill. I'm using it just to finish roughing that radius on the end of the slot. This goes alright. You have to index the inserts every part, but it gets the whole thing with 1 point. I think it was their 830 grade insert in this case. Now there could be some argument made to do that without flood coolant, but in this Inconel that probably wouldn't work. You have to use flood coolant on Inconel. That's what it looked like after that roughing. Then I run the plunge mill again. There's a big taper, a very slight taper. I can't even reach it here with this tool, but I get some of it, and it also eliminates having to run that finishing end mill into a corner and having chatter issues. See how close the machine is to the cabinet in the upper left-hand corner? Watch when it rotates a chuck, how close the machine's getting to that. The y-axis is almost hitting the cabinet there. See how close it is? So that's as far over as I could get with the b-axis. But it is enough to help with chatter issues going into that corner with the end mills. And I'll have to get the rest of it, or as much of it as I can, from the other direction when I turn the part around. So this is just sort of roughing again that corner with this. This is a 3/4 inch end mill with a 90 thousandths tip radius. And what I'm doing here is just finishing the top thickness or the height of the part in sitting in this orientation with it, and as well as roughing the sort of a rough finish pass on the inside to take most of the load off of my finishing tool, which is coming next after this. And then I bring this tool back later to do a little bit finishing of the radiuses with the corner radius of it and the end of the slot where I roughed it with the feed mill before. So here again, I'm not showing you all of this. It would take too long. This video would be hours long if I showed you everything. Here's the 1 inch end mill. This actually takes 2 passes. I'm just showing you one. Kind of a finished pass and a spring pass. But that 3/4 inch end mill before this takes a lot of the load off this tool. This tool's held up real well. So that's the slot. Just measuring the width of it. Here's a 1/2 inch bullnose end mill with a 60 thousandths tip radius that I'm using to finish the radiuses, surface the radiuses, I guess you'd say, on the OD and the end of the slot. I think I showed this shot on Instagram of the tool. And I also am using, in this shot, I'm using those lights on the windows. So I think that helps a little bit. It's me a little bit extra light in there, because the B-axis blocks the lights from above and it's pretty dark. So that's what it looked like after that end mill ran. You see, it puts those corner radiuses on the top and the end of the slot there. It kind of finishes some of those radiuses down to that point. Then I bring this 3/4 inch end mill with the 90 thousandths tip radius and finish it down to center line from both sides. There's a shot from underneath. There's a lot of coolant here. And, you know, with this whole video, there's lots of coolant. I'm trying to show you as best I can. Believe it or not, you're seeing better than I can see through the doors in this video. So that's what the end of the slot looks like with the surfacing. The half-inch end mill slightly touched that taper, but it's a very small amount. I was able to polish it out with the Scotch-Brite wheel. So that's this end of the part complete, and this end, that end in the center, I should say. And the next thing's going to be to flip it around and do the other end. But the other end is actually a very complicated machining operation. You'll see when I do it. Just trying to show these dogs that engage this tailstock, because I've had questions in the comments. So that dog, there's a plunger on the tailstock that engages that dog on the Z-axis, and the Z-axis actually drags the tailstock as well as the steady rest when you do it with it up and back. Just taking the part out of the chuck. And here's those, I was polishing off those little marks. They're very slight. It doesn't take too much to actually polish them off. Hit it with some sandpaper. In this machine, you can't run it with the doors open, any of the spindles, so you can't do that with the part in the chuck. So that's the finished part. It's ready to mount the next part in the spindle. So that's about it for this video. Thanks for watching, and all those who have just seen this the first time, please subscribe if you haven't already.